So my at-home experiment didn't work great. I was translating instead of just rotating. My chair isn't so awesome, so there was a lot of friction that was causing me to lose angular momentum, even though I was trying to show you a situation where angular momentum was approximately constant. I didn't have heavy weights. I had these pasta sauce things instead. And also I ended up getting like a little bit nauseous from trying to spin myself so much. So fortunately, I found a video of these other folks doing an at-home experiment that worked a little bit better to demonstrate our point. So we're gonna go ahead and watch it. So this guy wearing a physics t-shirt gets himself spinning really, really fast, faster than I'm willing to do, pulls his arms in, and you can see he starts spinning a lot to everyone's amusement. His friend, let me show you his friend doing it. He gets going really fast. And yeah, just can't handle it. So my question to you is why? And we can use the idea that the angular momentum in this system is approximately constant to figure this out. So if Einstein or a person in this demonstration starts off with their arms out, they have a really big moment of inertia, and they start off with a relatively small angular speed. But since there's nothing from the outside adding angular momentum to our system or taking angular momentum away, when they lower their moment of inertia, their angular speed has to increase as a result to keep the angular momentum of the system constant as it has to. So this has lots of applications, but the one you might be really familiar with is in things like Olympic diving, where you have these divers who are trying to get really high speeds so they can do a lot of flips. So they bring their body in tight to allow themselves to flip faster, even though their angular momentum is approximately constant. And then right before they enter the water, they want to slow down their rotational speed. So they make their moment of inertia really big so that their rotation rate slows at the right moment right before they enter the water. But another follow-up question I want to ask you about this is what is actually happening to their kinetic energy here in this situation? As Einstein pulls the dumbbells in, what happens to his kinetic energy? Does it increase, decrease, stay the same, or not enough information to tell? So take a minute to think about this, and then we'll talk about it.